All right, welcome back everyone. So the purpose of this video is to just get you started with the next kind of your turn exercise. And so I do really want this to be a your turn type deal, so I'm just gonna talk for a little tiny bit of the handout and then the rest will kind of be on your own. And so now we're gonna go down to this R0B intro R code handout. I can move myself. There we go. And so if you click that, the file should kind of open up. And this will kind of talk about what we did in the note packet, talking about models without any real predictors. And so the data set that we're using for this little R handout is a data set on professional basketball players. And so I think these are starting NBA players, I think in, 2014. And so the hypothesis test that we're going to do is we're going to determine if there's evidence that the average age of starting professional basketball players, of starting professional male basketball players in the NBA is different than 25 years. And so now, throughout this, you'll actually be changing code and kind of seeing how that impacts the results. And so if you just start by putting your cursor in this first code chunk, remember it's just Command Enter to run code. You should be able to read in this basketball CSV data set that has all of these variables: the player, the name of the player, their age, the 3-point percentage, their offensive rebounds, their blocks, their points, the team that they're on, the wins that the team are on. And then there's some like popularity variables, like how many page views their web page has, how many retweets they have in some sort of metric. So there's a lot kind of going on in this data set. As mentioned in the last video, though it wasn't really emphasized, we don't just want to read in the data set and have it appear. We actually want to name it something. And so we want to name it something so that we could use it. For other things throughout the rest of this file. And so in this case, if you run this line 28, we're naming the data set basketball DF. And I always name things with an underscore DF. That just stands for data frame. Not that that's super important. But after you name it, you should see it appear in your environment window. The athletes data set is still in mine, and now we see that we also have this basketball data set with 239 players and 12 variables. And so just like we did in the last handout, now that we've named this basketball DF, we could use this view function. And so we just use type in view and then open and close parentheses surrounding the name of our data set. If we run that, we could kind of open up this Excel. I keep doing that. Blurred. Phew. Okay. We could see this Excel type spreadsheet that has all of our variables that we could scroll up and down through. And so there are a lot of other functions that we're going to end up using. Another kind of useful one is this head function, which if you run that, that will just print the first 6 observations into your console window. So you could just kind of get like a little preview of what different variables are in this data set. And so the rest of this, again, I'm going to leave up to you. There's descriptions in this text of what all of the code is doing, and so you'll actually be kind of changing some stuff. The first part will have you do the calculations for the one sample t-test that we talked about in the note packet. The second part will go into graphics again, but this time actually explain what some of the code means, whereas last time we did graphics, we just ran the code and interpreted the result. And so you'll kind of practice changing stuff. If you get stuck at any point, the solutions are at the end. And so I'd recommend definitely trying on your own first because you'll learn the most by doing it yourself. But if you really get stuck, you could come down here and there's solutions to all the questions that are asked. Once you're done, you'll export it. You'll knit this file and then export it just like you did with the last handout, and so that way you're able to submit it to Sakai. As always, definitely let me know if you have any questions. I know getting started with R is difficult, but we're really hitting the ground running so that we're up and ready to go with using R to fit models as soon as possible.